Hi guys, I'm Pat Kelly. Okay, in this problem, they give us a function and they ask us to find the relative extrema and to verify using a graphing utility. Okay, how many times in your calculus experience have you been asked to find relative extrema? This is good, this is familiar territory. You know what you need to do in terms of the process. All that's new is that we've been learning about these hyperbolic trig functions. So of course the new material is going to come into play. But fall back on what you're familiar with. Relative extrema, you're going to start with the derivative. I kind of feel like in any calculus class, if I'm given a function, if I at least want to get a little bit of partial credit, I'm going to take the derivative. It's almost always the right first step. So when I go to take the derivative of this guy, of course you recognize that it's multiplication overall. So product rule, the derivative of the first is just 1 times the second left alone, plus the first left alone times the derivative of the second, and that's the new material then, right? You've got to know the derivative of these hyperbolic trig functions. And the derivative of hyperbolic secant is a minus hyperbolic secant still of x, but then also times the hyperbolic tangent of x. So there's my derivative. First step. Let's take another step and just clean it up a little bit. So this equals, and I think I'll factor out the secant, hyperbolic secant of x that's common. Hyperbolic secant of x times, just be a 1 left. Let's use this as subtraction now. X, and then hyperbolic tangent of x. Okay, got my partial credit in my pocket. I've got the derivative. Now what do you do with it? We're trying to find relative extrema, so hopefully remember we need critical points. To get critical points, we take this derivative, and for critical points, if you recall, there's actually two types. Type 1 and type 2. Type 1 is where that derivative equals 0. That's why I simplified a little bit ago, is with this factoring that we did, I now take each factor and set it equal to 0. So I've got the hyperbolic secant of x. I have to ask myself where that equals 0. And also that second factor in the parentheses, 1 minus x hyperbolic tangent of x. Also ask myself where that equals 0. Okay, two little equations to solve, and I'll give you a quick heads up. You're going to need some kind of graphing utility for this second equation. Okay, we're not going to be able to handle that by ourselves. So while you're grabbing your graphing utility or your calculator or whatever you're going to use for this, let me also quickly address the type 2 critical points here. Type 2 critical points are where the first derivative doesn't exist. This might not be perfectly obvious at first, but for type 2 critical points, there are none. You have to be able to address that though and make sure you understand why. In this case, why are there none? Well, for the first derivative to not exist, that would mean there's some kind of division by 0. I usually look for a denominator and set that equal to 0. You actually do have a denominator right there. Hyperbolic secant is 1 over hyperbolic cosine. But hyperbolic cosine is always positive. So the denominator here will never be 0. And actually very similarly with hyperbolic tangent, its denominator is hyperbolic cosine, which is never 0. So we have no type 2 critical points. I don't want to forget about them though. So I'm only going to get critical points from these two equations. Now this first one, you might have to think about a little bit. Not much though, because again, the answer is going to be none. So I say think about it because there's no real work to do. There's no algebra to solve. There are no values of x that make hyperbolic secant equal to 0. How do I know? Well, if you look at the graph of this hyperbolic secant is always above the x-axis. How do I know that? See if I know these graphs. This is again 1 over the hyperbolic cosine, and the hyperbolic cosine is that, it's called a catenary, but that hanging telephone cable. So if you take that and reciprocate it, you never have a 0 value for your y. So this has no values of x that give me a 0. If you didn't like that explanation, hang on to this for just a second, because I'm going to move to this other equation. And I warned you that I can't do this one without a graphing utility. So if you've grabbed yours, I'll quickly reference back over to this one. If you didn't like my explanation, you don't want to think about the graphs, try this guy in a graphing utility. Your graphing utility won't like you. It'll give you an error. There are no values, okay? But I am going to use a graphing utility for this equation, so I can't solve it on my own. So let me grab mine. And I am entering this left-hand side of the equation as my y, or y1, in your graphing utility. I'm going slowly with that because, even in explaining it, because most of your graphing utilities are not going to have this hyperbolic tangent as an immediate choice on your keypad or menu or whatever. So you might have to dig for it a little bit. So in my y1, I am putting 1 minus x. But in order to find this hyperbolic tangent, you might have to dig through some menus, or a catalog is what I have to go through. I'm bringing up my catalog, and I'm getting down to the t's, and there's my tan with an h afterwards, the hyperbolic tangent. I'll put that. Don't forget the argument of x. And now I'll graph it. I can see the graph of this guy. It actually does cross the x-axis a couple times, but I need those exact values. Sorry, those approximate values. So I'm going to use my graphing utilities capabilities to find the zero or zeros of this. I'm seeing the graph of this, so I even have a pretty good guess in terms of your left and your right bound. For me, from my left bound, just to play it safe, I'll go down to like a -3. I know I don't need to go that far. For my right bound, again, I'll play it safe and even say 0. Do I have a guess? Well, looks like it might be around a -1. So my calculator, my graphing utility, whatever you're using, has to think for a little bit. But I'm getting an x approximately -1.1997 if I round. Okay, there is a second zero, a second solution to this equation. So I'll use my graphing utility again with its features to find this. For my left bound this time, I'll say 0. For my right bound, I'll say 3. If you're picking up, there's a little bit of symmetry there. And for my guess, I'll say 1. And the symmetry holds true even in the answer here. The second value of x is a positive 1.1997. Okay. All right, good. So I have these two critical points after doing my derivative and finding the type 1 and type 2, or trying to find them. So my two critical points, remember what you do with those. I'll step over here. We do a first derivative test, which comes down to plotting those critical points on a number line, -1.1997 and a positive 1.1997. Remember, with your first derivative test now, then you're testing values in these intervals and seeing if they're positive or negative. Seeing if they're positive or negative when you plug them into your first derivative. Okay, so you could test anything to the left of -1.1997. I could just go to a -2 right away. I don't want to dwell on this. You're hopefully familiar with this process, but I'm going to take a -2 and plug it into this first derivative. And I'll be honest, I usually like to play with this in my head a little bit and see if I can figure out if it's positive or negative. You don't need to know the exact value. But this gets a little involved with those hyperbolic trig functions, so I'd resort to my calculator or a graphing utility, something where I can take that -2, plug and chug, and see whether this result is positive or negative. Okay? I have my results. This interval ended up being negative. This interval, make sure you test all of them. This ended up being positive, and this last interval ended up being negative. Okay? You should do that on your own. Make sure you're agreeing with those results. From those results, I know that my graph would look like it's going down, 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 and then it's going up, 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 and then it's going down, 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 which then tells me in the context of this problem, what was I trying to do? Find relative extrema. This looks like it's a minimum, right? Down then up. This looks like it's a max. So I think I have some answers here. Ready to get started to find some answers here. There's a little bit more work. So I think I have an answer of relative minimum at, and this critical point, of course, becomes my x-coordinate. My y-coordinate, I need to go back to the original function and plug that value of x in. So I'm going to go to my graphing utility or a calculator again, because especially with those decimals and these hyperbolic trig functions, I don't want to strain my brain. So I'm going to take that negative 1.997 and plug it in to my calculator or graphing utility here. But even as I do that, negative 1.1997 for x times, even as I go to try to enter this, here again, you're not going to have the hyperbolic secant typically as a glaring choice for you on a keypad or on your computer or your menu choices. You might have to dig for this a little bit. I'll even tell you that hyperbolic secant sometimes isn't even included, like in the catalog or the deeper menus. You have to know that this is 1 over the hyperbolic cosine, and that's what I'm going to have to do. Okay, so I'm going to start parentheses, dig through my catalog, find that hyperbolic cosine, enter negative 1.1997 as its argument. I have to close the parentheses of the hyperbolic cosine and then close the parentheses that I had started because I knew I wanted to reciprocate that. So now I'll reciprocate that. Hit enter. Now I've got my results. If I round, I am getting a negative 0.6627. Okay, that was from this critical point in the first derivative test telling me that it was a relative min. This also looks like a relative max. So I'll get ready for a second answer here. Relative max at my x value of 1.1997, comma, back to a calculator or a graphing utility, put 1.1997 into the original function. Don't bank on this, but you do actually have symmetry again, 0.6627. I did it already. I know that's right. Again, don't bank on the symmetry. Take that x value and plug it in. Okay? All right, and I'm done with the problem when they said to find relative extrema of this function. Derivative got me critical points. There were only 2 critical points. Critical points with the first derivative test showed me where max and min were. I found out the y values by plugging into the original. I'm done. But the problem also did say to verify using a graphing utility. So hopefully yours is still handy. What we'll do is we'll have to enter the original function into the graphing utility. Get mine entered. And there again, you're going to need to find that hyperbolic secant. I'm sorry, I already told you. You probably won't be able to find it. You'll have to find that hyperbolic cosine, but put it in the denominator, reciprocate it somehow. I think I've got mine. Okay, now I'll graph it. Depending on what your settings are at, you might want to zoom in once. I think I'm going to zoom in just once will do. I can see what's going on a little bit better. But I still want to verify my answers by using these features of the graphing utility. So I'm going to find the min and find the max. Make sure you know where those features are on your utility. I can calculate for me on my menu minimum, left bound. I have a really good feel for this because I feel very confident in my answers here. So I just need to be to the left of that. I could play it safe and say -2. Right bound, I could even say -1. Should work. A guess. My utility's asking me for a guess. I'd love to guess that. I know it's right, but I'll guess -1. It has to think for a bit. And what I'm seeing are exactly these numbers, both x and y, for the minimum, the relative minimum, within rounding. Feel good about that one? Let's finish this off by also confirming our relative max. Back to the calculation features, the calculus features of your utility. I'll choose maximum this time. Left bound, anything to the left of that, I could say 0. Anything to the right of that x value, I'll say 2. Your guess, I'll say 1. It'll think for a little bit. If it knows what it's doing, it's going to come up with this. It did. Okay, it confirms my same y value rounded to 4 decimal places. Okay. A lot of people like that verify with a graphing utility. It makes them feel like they did it right if the answers match. I always make it think like, okay, that means the graphing utility got it right because I know my answers are right. You should know yours are right. Okay? All right, that's it for this problem.